this meeting. All right, let me do this. Let me open this up. All right, this problem number 5 basically says copy another angle and then add 30 degrees to it.
Okay.
So there's the angle we're supposed to copy. We'll make it Q again using a compass. And then we're supposed to add a 30-degree angle to that without knowing what this is. We'll just call that X. Any guesses on how we should do this?
Maybe figure out not sure.
Here's what we know how to do so far. We know how to copy an angle, and we know how to bisect an angle.
Okay.
Right?
Yeah.
But we don't know how to copy a 30-degree. We don't know how to make exactly a 30-degree angle. And that's what we need to do here. In other words, this problem is really independent of angle X. This problem, the only way to do it is to copy a 30-degree angle.
Oh, okay.
Okay? And how can we copy a 30-degree angle? Well, 30 is half of what?
60.
How can we make a 60-degree angle? If we can make a 60-degree angle, then I could just bisect it.
Okay.
In other words, if that's 60 degrees, then I can bisect it and I'll have a 30-degree angle.
Okay.
Well, what figure has a 60-degree angle in it? What kind of triangle?
An equiangular triangle.
Yeah, exactly. So think about your compass. Remember what an equiangular triangle is also, it's an equilateral triangle.
Yeah.
In other words, that's equal to that equals that. Forget that X there. But an equiangular triangle is an equilateral triangle. An equilateral is stuff that you can do really easily with a compass.
Okay.
In other words, if you know one side, put your compass there. Excuse me, put your needle there and your pen there and draw an arc. That gives you side X. Then put your needle on P and draw an arc.
Okay.
And then put your needle back on N and draw an arc.
Okay. So
every point, every vertex has 2 arcs. So it's relatively easy to draw a 60-degree angle. Because it's one of the angles of an equilateral triangle. So if you can draw an equilateral triangle, then you can draw a 60-degree angle.
Okay.
And if you can draw a 60-degree angle, then you have to bisect that. And you will have a 30-degree angle.
Okay.
Now, the key is to do all of this on top of this angle. Now, let me scroll down here. And I'm going to do it a little bit bigger. First of all, I'm going to start my other angle like this. In other words, that was my original angle, theta. My goal was to copy this angle and then add a 30-degree angle onto it.
Okay.
And I don't know what theta is. Theta could be 40 degrees, 50 degrees, 62 degrees. It could be anything. My goal is to construct a 30-degree angle. And I made it slightly not horizontal on purpose.
Okay.
Right? So what I have to really do is construct an equilateral triangle on that. And then bisect one of the angles.
Okay.
Okay, equilateral triangle is all three sides are the same. So set your compass on this measurement. Make an arc. It doesn't have to be all the way up there. It doesn't really matter. I can make an arc here from here. So that's where the needle is. That's where the pen is. And then make the same arc over here. That's where the needle is. That's where the pen is.
Okay.
And then leaving the measurement the same, go to either one, go up here, put your needle, and measure an arc to here.
Okay.
So now we know that this side is equal to this side is equal to this side. And the way we know that is our compass is set on that distance right there.
Okay.
If I make a triangle with three equal sides, then I have an equilateral triangle.
Okay.
All right, now that's 60 degrees. Let me point to it. That is 60 degrees. I got to bisect it. So let's look at this picture. I've got to come up with a line that's halfway between that angle, and I will have my 30-degree angle.
Okay.
Now, it's very difficult for me to get you to explain what we're supposed to do. I can explain it relatively well. Here's what we're going to do. Or maybe you can explain it. I'm attempting to bisect that angle.
Okay.
So I put my needle right there. What do I do?
So you're gonna want to choose a point that is less than half of the n the like
Not
NP.
yet. Not yet. That's the second part.
Okay.
The first thing I want to do is to cut out two equal parts of this line. In other words, I will put it right there. So I set my compass distance from N to P, and I cut out that distance, and I cut out that distance. It's
Okay.
really important to understand that a compass is only one thing. It is a measurement tool, like a ruler. You're
Okay.
measuring from here to here. And then you're just making equal distances. So that distance is the same as that distance.
Okay.
Okay? Now, this is where you go to each of these secondary points here. You put your needle on this point right there.
Uh-huh.
And here is where you have to have it set on more than half the distance. So it's
Okay.
more than half that distance right there.
Okay.
And make an arc. As long as it's more than half, you're going to end up with an arc that looks something like this. Right?
Okay.
An arc surrounding
Yeah.
this point right there.
Mm-hmm.
Put your needle on the other point right there, leaving your distance the same. Make another arc, and you will get that. Once you get
Okay.
two arcs, you're going to connect the three dots, the vertex and the two intersections of those, so that you get that. Well,
Okay.
if that big angle was 60 degrees, half of it is 30 degrees. So
Okay.
there is your 30-degree angle constructed on top of an unknown angle theta.
Okay.
In other words, here's your unknown angle theta, and we have put a 30-degree angle right there. And
Okay.
that's what they were looking for you to do.
Okay.
Now, we have a little bit of time. Let's look at the other parallel problem here. Now, let me open that page up. Hold on a second. Number 4. We just barely kind of talked about this the other day.
Yeah.
Here's what I'm going to do. I described it, but perhaps not very well. So, I have a line over here. Let me not draw it there. Let me draw it up here. And I have a point, Z.
Okay.
And I want to draw a line through Z that's parallel to my line here.
Okay.
Well, the first thing I do is draw a straight line that represents a transversal.
Yeah.
Now, I still haven't drawn my parallel line. My parallel line is going to be parallel to this bottom line. But what I know is that however the parallel line needs to go, this angle has to equal this angle.
Okay.
Okay, so let's go back. And this, in other words, that's alternate interior angles. If those two angles are equal to one another, then those two lines are parallel. So the problem really is to recreate that angle. Okay, this angle right here. Only we want to do it from point Z. What?
Okay.
It's easy enough to do. What we have to do is put the needle right there.
Mm-hmm.
Remember how we copy an angle. We make an arc there and another arc there.
Mm-hmm.
And we go down here and we put the point. As long as we're doing that, let's do that same thing up here at Z. Turn the compass around, make an arc there and another arc there that's the same distance. You with me?
Yeah.
In other words, this distance here is the same as that distance is there, which is the same as that distance, which is the same as that distance.
Okay.
Okay? And so far, we don't have that dotted line there. We're looking at a solid line. But we're looking at all these hash marks that we got from our compass. Okay, then we go down here, we put the needle there, the pin there to measure this distance.
Yeah.
We go up and we know the needle has to go there. We make an arc of that distance, PN, and it does that. Now we have an intersection point which we can connect with Z, and this angle here is the same as that angle there, and therefore we have alternate interior angles, and this line ends up having to be parallel to the bottom line because angle 1 is equal to angle 1. In other words, we took angle 1 and we copied it starting from Z. So what we really did is copy it upside down. So you could do every single process that it takes to copy an angle and turn the piece of paper upside down and start with Z and that transversal and copy the angle to there.
Okay.
If you do that, you'll have a line that's parallel with the bottom line.
Okay.
Okay? And that's what this whole picture kind of means. It wasn't clear to me when I first looked at it, but he wants you to take that angle and duplicate it right there.
Okay.
So you put the needle there, you make an arc there, you make an arc there, same arc, make up here and there, and then you go to one of these points and you use the distance to make the second arc up there, and that gives you your intersection point, which you can connect with Z. That's
okay.
The process. Now, as I've said before, construction is kind of a hard thing to teach you because I can't watch you do it.
Okay.
So make sure that if you have any problems at all with it, you know how to get to this site.
Okay.
And construction of 60 degrees, 120, 30, or 90. So when I was looking how to construct a 30, then I start with an equilateral triangle. And once I have an equilateral triangle, I can bisect one of the angles, and that's 30.
Okay.
So this page here is pretty good for constructing 30, 60, 45, 90, all of your really common angles.
Okay.
And this actually is not what I had the other day up, but this one is actually helpful. This was the only one I could find that helped me construct a 30-degree angle.
Okay.
I didn't know how to do that until I found this page. You have to start with an equilateral triangle. All right. Well, Jonathan, your test is tomorrow.
Yep.
Well, I hope you get over that cold you got. It took me 4 days to get over it. I've been fighting the flu for 4 days.
Yeah.
And good luck on your test. Have a Merry Christmas and a Happy New Year, and maybe I'll talk to you next semester.
Okay.
All right. Have a good one. Bye-bye.
You too.